Hey everybody, this is Mr. Johnson, and we're going to be finishing out the PM2 Notes today. Just two problems left to do, but they are the most complicated questions in the notes packet. You're really going to see here how permutations and combinations can be very powerful when it comes to figuring out probability, the odds of something happening. So if you recall from last class period, we ended by figuring out if things were permutations or combinations. If you flip to your notes, we had a whole bunch where we were just identifying. Now I want to point out to you that there is a way to do this entirely on your calculator, which is pretty nice. So for example, in the notes, part J, how many different 7-card hands can be chosen from a standard 52-card deck? You could figure that out by using the math and the formulas that we did, or you can use your calculator, and this is really why a graphing calculator is beneficial. All we have to do is figure out if it's a combination or a permutation. Does the order matter, meaning it's a permutation, or does the order not matter, meaning it's a combination? So for this particular example, it doesn't matter what order you draw the cards in. What matters is the hand you're holding. It can be in any order you want. So we're going to go ahead and we have to tell how many we're choosing from, which is 52. And then we have to go over to math right here on our calculator, and we're going to arrow over to probability, and then we have two selections, NPR, which is a permutation, and NCR, which is a combination. N stands for the number we're drawing from. R is another name for K. It's how many we're drawing from that total, which is our first number. So in this case, we're drawing 7 cards. So I'll go ahead and go down to NCR. Since this is a combination, the order doesn't matter. I'll hit enter, and now I just have to go ahead and put 7, the number of cards that are going to be in my hand. So out of 52, I'm choosing 7 cards. Enter, and I have this many different options. Pretty impressive. The same thing goes for permutations, except you would just go to the math, over to probability, and then use the second option. Pretty simple. So with problem number 14, a school offers 2 reserved parking spaces to its students with permission to drive to campus. Each month, a student council member conducts a golden ticket lottery during an all-school assembly to choose the 2 lucky drivers. On one occasion, the person doing the drawing was an AP Stats student. When both students chosen were members of the same AP Stats class, some observers complained that the drawing was unfair. So how unlikely or how likely is it that the event would happen if there were 120 eligible student drivers and there were 30 people in the AP Stats class? We're going to do this using 3 different methods. It's kind of cool that all 3 work in this case. So the first method being the general multiplication rule. In order to find this, we need to figure out what are the odds of them being in the stats class out of the total. Alright, so if we are thinking through this drawing in a series of 2 drawings, 2 stages, the first time you are drawing a name from that hat, there are 30 possible students that you could draw from out of 120. But as soon as you draw that name and you announce it, the odds are going to change slightly afterwards. Kind of think of that conditional probability we did in the last chapter. There are now only going to be 29 students left out of 119. So the odds keep getting smaller and smaller. That's a little bit of the factorial thought coming in here. So 30 times 29 is 870. 120 times 119 is 14,280. If I just go ahead in my calculator and I divide those out, so 870 divided by 14,280, I will get 0.060924 blah blah blah. That is a 6% chance that 2 AP Stats students would be chosen out of 120 people total. So the odds aren't great, but it's not like they're non-existent. They could happen every once in a while. So let's see how this is done using permutation. This means the order matters. So maybe the first person, if their name gets drawn, they get the first spot, the spot that's closest to the school building. And then the second person gets the second spot. So a little bit further away, but still a pretty decent place to park. So again, it's still the same idea. We're looking at the stats out of the total. What are the odds that they are from the statistics class? That's what everyone's complaining about. So for permutations, if you remember in our notes, we have this formula, n factorial over n minus k factorial. And we're going to have to do that for the stats class and the total. So if we were setting this up in calculator, if we were going to enter this in a calculator, it would be 30p2. Out of the 30 people in that class, we are choosing 2 of them. Okay, and the order matters. That's why we're using a permutation. For the total, we're going to go ahead and out of 120, we are picking 2. So we're dividing these two things, the number specific to the statistics class and the number specific to the total. If you are looking in the background, this is going to kind of work out to be 30 factorial over 28 factorial for the top, and then 120 factorial over 118 factorial. If you are going to take a stats class in college, they will probably require you to do the math this way. So I'm just trying to prepare you for that. Putting that in our calculator, we're going to get 870 on top and 14,280 on the bottom. If we put that into our calculator, 870 divided by 14,280, you can actually see I've already done that in the previous problem, and I get the same answer, 6% chance. So that's kind of crazy that we get the same answer either way, 6% chance and 6% chance. But what if we do it the last way? Meaning, what if we try combinations? So combinations, if you recall, mean that the order doesn't matter. So they pick these two names, and these people don't have to go in a certain spot. They just get the spot, or the spots that are closest. They have to figure out who gets which one. So again, the same idea, stats is on top out of the total. The little formula with combinations is slightly different because it has k factorial on the bottom. So we would, if we were going to be doing this with only numbers and not really any calculators, have to do 30 factorial over 2 factorial, 28 factorial. And then we'd have to do 120 factorial over 2 factorial, 118 factorial. I am not that mean. I'm not going to make you do it by hand. We can use our calculator. So 30 combination 2 and 120 combination 2. We're going to get 435 over 7,140. Now, just to remind you, putting those things into the calculator is not that hard. So let's clear this out. I'll do the top of the fraction. So I need to hit 30. That's the total number of people I'm choosing from this class. I hit math. I go over to probability, which a neat little trick. If you hit the left arrow, it jumps you all the way over to the right. And then combination, NCR, and then I'm choosing 2. That's how I got 435 in this case, which is right there, 435. So I divide these two things. 435 divided by 7,140. And guess what I get? 0.0609243. And it just keeps on going. These are all the exact same thing. 6% chance. So depending on how you think about your problem, whether or not you think multiplying would be easiest, or permutations would be easiest, or if the order doesn't matter, maybe combinations would be the best, you're going to get the same answer for this problem. What about the last problem in the notes? Question number 15. Janine wants to set up a playlist on her iPhone with 8 songs. Now she has 75 songs to choose from, including 15 by Fall Out Boy, 12 by 21 Pilots, and 10 by Maroon 5. So she has a bunch of other songs that we don't know who they're by, but we do know those particular songs. The question here, how many different sets of 8 songs are possible for Janine's playlist, assuming that the order of the songs doesn't matter? Who cares if it's a certain Fall Out Boy before a 21 Pilots song, or if those two are switched around? It doesn't matter. So since the order of the songs doesn't matter, that means it's going to be a combination, not a permutation. Permutation is the order matters. So I need to take the total number of songs, which is 75, and I am choosing 8 of them. In my calculator, it would look a little something like this. 75 goes down first. Go to the math menu, over to probability, and this needs to be a combination. And I'm choosing 8 out of the 75. You'll notice my answer is in scientific notation. 1.687105373E10. That means times 10 to the 10th power. It's scientific notation. Now, I didn't happen to write down all the decimals. You can do that. That's usually the best practice. I was just a little lazy with my answer key, and so I didn't write that down entirely. Now, that number is in the billions, so there are a ton of different ways to have this playlist work itself out. So what if we look at the next part of the question? How many different 8-song playlists can Janine create if the order of the songs does matter? So we are not going to be using combinations, we're using permutations now, because if I switch the order of one song and the next song, it's going to make a different playlist in her head. So again, it's still 75 songs that I'm choosing from. Go over to the math menu. This is a permutation. Still choosing 8 overall. You'll notice this is 6.802 times 10 to the 14th power. Because the exponent is much bigger here, this number is larger. It's actually 680 trillion instead of 16 billion. That's a pretty big difference. And that's because switching the order of just 2 songs creates a new playlist. So let's go ahead and let's look at B. How many 8-song playlists contain only songs by Fall Out Boy? What's the probability that this happens if she decides to let her iPhone select the 8 songs at random? So this is actually a pretty applicable question. I've wondered this, what are the odds that I get 5 songs in a row by this certain band? So we have to know how many songs Fall Out Boy has on her iPhone. So if we look back, there are 15 total songs. So out of those 15, I need to choose 8. How many different ways can we arrange those if the order matters, okay? We're just going to stick with permutations for this problem. So 15p8 turns out to be 259,459,200 different possibilities. If we are trying to find the probability, we're going to have to do something similar to the previous question. The probability of Fall Out Boy out of the total. So Fall Out Boy, that would be this right over here, 15p8. So we put that on top. The total number of songs we actually just found in the previous question. It is 75p8. So if we divide these two things on our calculator, we have to be a little careful. One thing I always try to do, I try to wrap things in parentheses to keep them on the top and then on the bottom to separate those two. So we'll do 15. We'll go over and use a permutation, and we're picking 8. Notice how I close the parenthesis, and that traps everything on the top in this top red bubble. Then I have to hit divide, and I'm going to close everything in on the bottom. 75 songs to choose from. Permutation, choosing 8. If I hit enter, I get 3.8 times 10 to the negative 7th. So that means, since it's a negative exponent, I have to move my decimal 7 spaces to the left. So I get 0.00000038. 6 zeros in front of the 3. Now that, as a percent, is 0.00003%. Teeny, 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 tiny. The odds of getting a playlist that are all Fall Out Boy, extremely small. It will hardly ever happen. Maybe 1 in a trillion times or 1 in a billion times it'll happen. Part C says, how many 8-song playlists contain no songs by Fall Out Boy? What's the probability that this happens if she decides to let her iPhone choose these 8 songs at random? The first thing we're going to have to do is figure out how many songs are not Fall Out Boy. So if we know that there are 15 total Fall Out Boy songs, that means 75 minus 15 leaves us with 60 to choose from. So I have 60 that I can choose from. The order matters, and I'm choosing 8 of them. So that's this number right here, 1.03 times 10 to the 14th. That's a lot of different ways that we can have this playlist work itself out. Again, if I'm trying to find the probability that there are no songs, so no Fall Out Boy songs is this number, it needs to go on the top. This is out of the total, right there, of 75 songs, and I'm choosing 8 of them. I think the easiest way is just to enter that in your calculator, so you don't have to push a bunch of numbers, okay, even though you can figure out those answers. So 60 permutation 8 divided by 75 permutation 8. And I actually get 0.151657. That's a 15% chance that there's no Fall Out Boy on the playlist. So some people are tempted to think, oh, I got a really small percent up here for if the playlist is all Fall Out Boy, so I'll just take 1 minus this, and you can't assume that. You can't assume this because a lot of those playlists are going to have maybe 1 or 2 songs by Fall Out Boy. It could be a mixture, and that actually makes up a majority of those options. So 15% of the time, we're going to have a playlist with no Fall Out Boy. Part D, what is the probability that all 8 songs are by 21 Pilots? Similar to what we did earlier with Fall Out Boy. How many songs were by 21 Pilots? Well, there are 12 of them. So out of those 12, I'm choosing 8 for this playlist. I need to divide this by the total, which the total amount is 75, and picking 8. If I do this on my calculator, I get 2.934 times 10 to the negative 8. So that's 7 zeros in front of a 2. Very, very small amount. If I change that to a decimal over here, moving my decimal space twice to the right, it's 0.000002%. That's even smaller than before. Scrolling back up to part B, comparing these two numbers, this one's smaller. Why is it smaller? Well, if we go back to how many songs each band produced, Fall Out Boy had 15, whereas 21 Pilots only has 12. If you have less things to choose from, the odds of that thing happening are going to be smaller, which is kind of interesting. And the last question for the notes, what's the probability that all 8 songs are by 21 Pilots, Fall Out Boy, or Maroon 5? It can be any mix of those 3 bands, but we don't want any of the leftovers. So we have to know how many songs each band produced. Fall Out Boy had 15, 21 Pilots had 12, and Maroon 5 had 10 songs. That's a total of 37. So out of those 37 songs, I have to choose 8 of them. So 37p8. I'm going to divide that by the total, which the total is still 75p8. If I do that, I get 0.0022884, and it continues on. Moving my decimal, that is a 0.2% chance that your whole 8-song playlist is entirely stuffed by Fall Out Boy or 21 Pilots or Maroon 5. Not great odds. Yeah, it won't happen very often. Maybe once out of every couple hundred tries, but over the span of a year, it might happen once or twice. Hopefully this video helped out a little bit. Just remember to use your calculators and kind of write out what you are putting in your calculator. On your quiz, you're going to be required to do that, so I know exactly what math you are doing. The rest of the day should be a work day. Hopefully I will have a key ready for you guys. If not today, probably tomorrow, so you guys can check your work and make sure you're doing everything correctly. Thanks, guys, and I hope to see you all soon.